afternoon with Anthony presenting to you. So over to you, Anthony.
Thank you, Clinton. I'd like to say hi, everybody. As Clinton mentioned, today's presentation is about learning and teaching Year 12 Physics and applying the new study design for 2024. I'll better click on the right screen. I've taught physics for a number of years. I came to Edrolo and worked on the junior product. I'm now leading up the new Year 12 Physics book for next year. Just an outline of what we're going to be covering today. So just the major changes to the study design for Year 12 for next year, what they mean for you, your teaching, assessing key science skills, which have become more and more relevant in Year 12 Physics, applying knowledge to new context, which is also becoming more and more relevant, and streamlining your teaching using Edrolo. I will have a little section for questions at the end of each one of these sections. So you don't have to wait all the way to the end. If you have a question, you should be able to ask it whenever you want. So what are the changes to the new study design? The major ones, as you can see here, would be that mechanical waves, properties of mechanical waves, has moved to Year 11. To kind of combat this restructure, more than removal, with the next year, we're going to add a waves recap to really just refresh students' memory of the basics of waves, and also for the few students that haven't done Year 11 physics and go into Year 12s, they need a bit of a recap. We do the same thing with forces at the start of the year in Unit 3 Area Study 1, and with electricity just before we do transmission of electricity, we do a little recap to remind students of their basic electricity laws. Production of light and matter is gone. That makes it a bit easy. Not that it was ever assessed that often in terms of LED lights and stuff, but the biggest changes really come from generation of electricity, where there's a new study design dot point on PV cells. That would probably be the only brand new thing in the study design. There are some changes to relativity. The major one being relativity's moved from Unit 3 to Unit 4, which I think it fits a bit better there. And there's a couple of new dot points in relativity, which we'll go over today, which I say they're new, but I don't think they're necessarily new content when it comes to your teaching. So they're the major changes for next year. So far, are there any questions about the changes or what I'm going to cover today? Nope. All right, fantastic. I'll keep going. All right, so let's start with the biggest one, which is photovoltaic cells. And the study design dot point is to describe the production of electricity using photovoltaic cells and the need for an inverter to convert power from DC to AC for use in the home, not including details of semiconductor action or inverter circuitry. So the main thing there being it's describe. So they're not going to be asked to do calculations, electricity calculations. And when you're describing the production of electricity, it's a bit vague. You can't go fully into semiconductors. So the fine line we've treaded is that the semiconductors are used to produce electricity. So we have two types of semiconductors. One type absorbs sunlight, ejecting electrons. They are attracted to the other type and flow around the circuit. This is a diagram that's taken from our new book. It's still in an initial typesetting phase, so these aren't finalized, but this diagram here shows, in a nutshell, all the students really need to know in terms of how a PV circuit produces electricity. The second half of that dot point, which is an inverter, the only real thing you need to know about an inverter is that it converts DC to AC. And our electricity grid, current electricity generally runs on AC, so they're needed to integrate it. The big question is, how might they assess this? If I were to look into a crystal ball, I could definitely see this being kind of introduced in a transmission question. It sits just after generation of electricity and just before electrical transmission. So hypothetically, VCAR could write a question on a solar array generating electricity. It's then run, the DC electricity is then run across 2 kilometers of cable to an inverter. Calculate the power loss. What if you move that inverter right beside the solar array and then ran it through 2 kilometers of power line? What would be the differences? If I were to look into a crystal ball, I would say that would be a pretty good application that really integrates it into already existing exam questions and study design dot points. And here we have Unit 4 Area Study 1, discuss the importance of the idea of quantization in the development of knowledge about light and explaining the nature of atoms. Now, this is not really new. It's a new dot point on its own, but the content is not new. The importance of quantization has always really been in the study design, especially when you're talking about absorption and emissions of photons, but it's never specifically been its own dot point. So it links well with electrons forming standing waves, because the standing waves is what causes the electron shells in terms of their distinct energy levels, and that would be your link to the nature of the atoms. And it also links in with the absorption and emission of photons by an atom, because your light of particular frequency is emitted due to the electrons jumping between these distinct energy shells. So they're the kind of 2 links when you're talking about quantization. Again, not really new content, just kind of a study design dot point on its own. The Michelson-Morley experiment. So the Michelson-Morley experiment would be familiar to many experienced teachers here. It does appear in many textbooks already as one of the key pieces of evidence, but I suppose it's new for this study design. So it's interpret the null result of the Michelson-Morley experiment. So here we have a diagram from our new textbook of the Michelson-Morley experiment, or a very similar experiment, we'll call it. And it shows the Earth orbiting the Sun and a light source splitting into 2 different beams, one parallel to the Earth's velocity, one perpendicular to the Earth's motion. And what Michelson-Morley were aiming to do is really determine the existence of the ether. They said if Earth is traveling through this hypothetical ether, they should measure a difference in the speed of light between the light going parallel and the light going perpendicular. The null result showed that they didn't measure any difference in the speed of light at different times of day or different times of the year and different seasons, and therefore this is one of the key pieces of evidence that supports Einstein's second postulate, that the speed of light is constant regardless of the motion of the observer or the source. I am going a little bit fast through some of these, but I'll slow down if anybody wants me to. That brings me to one of the this probably would cause most teachers the biggest consternation. A, because it is special relativity, and B, because these dot points, in my opinion, don't make sense. I don't think they're very good dot points, and I don't think VCAR can really ask too much about them. So muons reaching Earth has been in the previous study design and the one before, if I remember correctly. So that's not new. However, particle accelerator lengths must be designed to take into the effects of special relativity into account. Now, if we apply that simply to a linear particle accelerator, like the Stanford linear accelerator, then we can say that a particle traveling at a constant speed along the linear accelerator in its own frame of length will travel a shorter distance or a contracted length. That's a very, very straightforward interpretation of that dot point. If you take a circular particle accelerator and try to apply this, that's when you run into trouble. If a particle's traveling around a synchrotron or a circular particle accelerator, then it's undergoing circular motion, and so it's accelerating. So you can't apply special relativity to that. If you tried to say that, okay, a circular particle accelerator has straight parts and curved parts, and then along the straight parts, you can apply special relativity, which contracts the distance the particles travel. You could make an argument that reduces the circumference of the circular particle accelerator. That's a pretty far bow to stretch. I think realistically, what they were thinking is that whoever designed this probably wanted to get to the fact that from the particle's frame of reference, it is traveling around a smaller circumference, and therefore it takes more energy to accelerate it around that circumference, but that can't be applied to special relativity because circular motion is acceleration. So at the end of the day, when designing a particle accelerator, really the only thing VCAR could ask is, in the particle's frame of reference, the linear accelerator will be contracted. How does that affect the design? We need to design them longer. And I think they can't ask anything about circular particles traveling in a circle really, unless they split it up into straight and curved sections and only considered length contraction in the straight sections. So again, I think, I'll get to that at the end. I think this is just a new application for them to ask in an exam. Every year they've asked muons for a long time, so this just gives them another way to ask the same length contraction time dilation questions. And that also brings me to time signals from GPS satellites. Again, I don't think this is a very good dot point for a number of reasons. The number one reason being, again, GPS satellites orbit the Earth. They're traveling in a circle. They are undergoing acceleration. But the second reason, if we were to assume that a GPS satellite has a horizontal velocity at a certain point, when the time signals are sent, then according to our clocks, we would see, well, if we were to measure their time, we would see their time tick slower. However, for the speed that GPS satellites are traveling, that is an absolutely tiny amount, which does affect their accuracy, and that the clocks tick slower. But the real issue with GPS satellites is actually got to do with general relativity, and that's actually, the problem is that they're very close to Earth. So their gravity is weaker than on the surface of the Earth, and that has a far greater effect on their time signals than special relativity. So even though from our frame of reference, according to special relativity, their clocks would tick slower, according to general relativity, their clocks actually tick faster. So we actually have to slow down their clocks, not speed them up. So again, it's a bit of a silly dot point, because although, yes, we can apply special relativity and we can say that the satellite clock ticks slower, therefore we need to speed the clock up. In reality, GPS satellites' clocks tick faster due to general relativity. We actually need to slow them down. So it messes with somebody's sense making, and any kid researching this online will probably come to the same conclusion. But again, at the end of the day, they can only really apply basic time dilation and length contraction questions to this. So it's really just two more examples or context at which they can apply time dilation and length contraction, because muons have been used over and over again. So although these are new and a bit weird, they don't really, well, I don't think they will change your teaching of time dilation and length contraction, because really they're just new applications of the same theory. That brings us to, all right, so again, in relativity, new dot point, which is apply the energy mass relationship to mass conversion in the sun. That's been in the study design for a while. To positron electron annihilation and to nuclear transformations in particle accelerators. Details of the particular process are not required. All right. So again, we're talking about mass energy. They've used mass energy conversion in the sun for quite a while now. Positron electron annihilation was in year 11, but not in this regard. Essentially, there are two different ways that positrons and electrons can annihilate each other. If we're talking about particle accelerators as well, you can have a low energy positron electron annihilation, in which your electron and your positron have a very, very low kinetic energy. So essentially, you can represent it using their mass energy. They annihilate each other completely, resulting in all the mass being converted into energy. And that's quite straightforward using their rest energies for your equations. So that's a very straightforward application of mass energy. The slightly more complicated example would be a high energy annihilation, in which your electron and positron have a high kinetic energy. A high kinetic energy means that after they've annihilated each other, the extra energy provided by the kinetic energy can produce particles, can produce other particles plus energy. So in particle accelerators, particularly if you fire, and this goes to nuclear transformations and particle accelerators, if you fire two high energy particles at each other, because they have kinetic energy, they can actually, mass energy conversion says that kinetic energy can be converted into mass. They can produce particles which are heavier than them. So again, there's no new real theory here. We've just got two extra ways that you can apply mass energy. And this would probably be because they've used mass energy in the sun too many times. It's just another couple ways that they can apply mass energy in questions. So there's no real new theory, just new applications of the same theory. And they would be the biggest changes, especially with these last three in relativity, which get a bit confusing. Does anybody have any questions related to any of those changes that I went over? No. Please sing out if you do at any time during it, because yeah, I'd love to hear your input.
David's just posted Anthony in the, a question: wave light duality gone?
What do you mean, Dave? Can I ask? Like, in terms of light duality, in terms of particle and wave? Yeah, no, that's still in there. Light as a particle and light as a wave is still in the study design. Has not really changed at all. So it goes light as a wave, light as a particle, duality, and then it goes into relativity. So if I go back to the start, I can quickly show you. So on the right-hand side here, we have light as a wave. It's still in there. Light as a particle. Matter as particles or waves. Similarities between light and matter. And then we get into relativity. Does that answer your question?
It's a handy summary that graphic, isn't it, Anthony? So if you missed it at the start, we're sending these slides around afterwards, so you'll have reference to this, and that's all good from David.
Sorry, I might not have explained it properly. On the left-hand side, I should have done this, but I forgot. On the left-hand side is the old study design, and so I've color coordinated it. And on the right, I've got the new study design, and the colors match up, and you can just see they haven't changed that much. They've just kind of rejigged it a bit. So properties of mechanical waves is gone to year 11. Whoops, I'll go back. But light as a wave is still there. So Einstein's theory of special relativity was over here in unit 3, so it's red, is now over here in unit 4. And they've switched it around so that fields interactions and the effects of fields and applications of fields and concepts we started with has now moved into unit 3 area study 2, and we actually now start with Newton's laws of motion and the relationship between force, mass, and energy. I really should have explained this at the start. Thank you. That was a very good question, Dave. So I talked about the new study design dot points. I forgot to talk about the restructure of the study design. I think this restructure makes a lot of sense because I don't really know many teachers, most of the teachers I knew were starting with Newton's laws of motion every year anyway, and then going into fields and interactions. So moving Newton's laws of motion to the start of the year makes a whole lot of sense. We go into energy and momentum. We then go into fields and interactions. The effects of fields, that's your gravitational, magnetic, and electric fields. Application of fields concepts, that hasn't changed. So you're still talking about your Kepler's laws. What else? I can't remember off the top of my head, but that's still application of your same electrical, magnetic, and gravitational fields. Over here, generation of electricity, the only new study design dot point really is that photovoltaic cell one. Your classic generation of electricity in terms of your particles and your generators and alternators is the same. Transmission of electricity is almost the same. Light as a wave is still here. They've just moved properties of mechanical waves to year 11. So the big deal here is that because they've moved that to year 11, we are including a chapter here, which is basically a recap of properties of mechanical waves from year 11, just to refresh students' memories before they get into light as a wave. Light as a particle, matter as particles and waves has not changed. And the similarities between light and matter has not changed. And once again, we finished with the practical investigation. Thank you very much for sparking this, and thank you, Clinton. Are there any questions on this, the restructure and kind of the new study design dot points? Because they would be the major things. Cool. I'll move on a little bit. So they are the major changes. They are the major study design dot points that are new. I hope that I've made it pretty clear that apart from photovoltaic cells, there's not really much new theory to teach. It's more about new applications of existing theory. So your teaching and learning in year 12 really hasn't changed that much. The structure of your teaching hasn't changed too much. I think most people would start with Newton's laws anyway. So there's not that much new there. The Michelson-Morley is new. All right, there are some new key science skills. Well, not new key science skills, but there has been an increased focus on key science skills in previous study designs and with this study design too. So we've got the key science skills chapter, again, from the year 11 textbook. We'll have a similar one in our year 12 textbook this year about all the key science skills. In the new book, we've got a whole bunch of practs, which are all editable Word docs We got student docs, and teacher and tech docs to help you, give you the answers as well. We got fully worked question and answers to all our pracs and explicit key science skills. So every prac is explicitly linked to key science skills in the study design dot point to help you and help your students get assessed on the key science skills, which have an increased in their importance in recent study designs. We've got risk assess ready for you to sign, and we also include useful tips. So assessing key science skills through your practical classwork is really, really straightforward. There has been some changes in the study design in terms of the wording that you use. So if we're talking about key science skills, repeatability is now the closeness of the agreement between the results of successive measurements of the same quantity being measured, carried out under the conditions. So really we're talking about trials. If you do 5 trials of a measurement, that's now called repeatability. Reproducibility is now the term they use for the closeness of the agreement between results of measurements of the same quantities being measured, carried out under conditions of measurement. So we're talking about 2 different experiments being reproducible is now the new word they want to use. Precision is a measure of the repeatability or reproducibility of the scientific measurements and refers to how close 2 or more measurements are to each other. The word reliability has been removed from the study design. So they no longer refer to reliability. It's repeatability, reproducibility, and precision. Repeated measurements are made to reduce the effect of random errors and reduce the likelihood of mistakes. The study design dot point also says mistakes are not an error. So if a student says made a mistake in this measurement, they should actually repeat that measurement until it's not a mistake. So it's not an acceptable error for students to write down, if that makes sense. The definition of accuracy has not changed. So some slight wording changes for our key science skills as well. Okay, uncertainty in physics. Well, this is one that physics can't really, well, has never really agreed on. Essentially, there's only 3 things that in VCE physics that a student needs to be able to do with uncertainties. They need to be able to recognize the representation of uncertainty, i.e. the uncertainty of this temperature is plus minus 2 degrees, or graphically as uncertainty bars. Draw uncertainty bars given a numerical representation of the uncertainty, and you would have seen this in previous exams, that it's very common for them to ask students to draw uncertainty bars on their diagrams. Sometimes it's almost impossible to get those uncertainty bars accurate on the scales they give in exams, but students should at least be able to draw it in the correct direction, X or Y, and to state the numerical value for uncertainty given a graphical representation. So those are the only 3 things they can ask you with uncertainty. So do not spend much time adding, subtracting uncertainties. Is outside the bounds of VC physics, as is multiplying them. Although, and for the longest time, I don't think it's ever been assessed on the exam. That may change given the chief examiner and their mood. But those are the only 3 things they can ask you about uncertainty. So do not worry about uncertainties and don't spend too much time would be my recommendation. When given a graph, this is not strictly from the study design, but the same thing. You can only read values, calculate a gradient, or calculate the area under the graph, or use those values for something else. In our textbook, we're including again these nice strategy boxes to help with counting squares or any other useful tips and strategies for students on their exam for their exam technique. Are there any questions on the key science skills? Is that reflective of what happens in research science, or is this another fad? If Are we talking about repeatability, reproducibility, and precision? If I were a betting person, I would put it on a fad. There is also the new term of personal error that they've included in there. Not human error, personal error. I'm not sure where that came from, but I would assume that is also another fad. So these are the words they give us. So these are the words we try and use, unfortunately. Good question though, David. Thank you. All right. So applying knowledge to new context. Increasingly, if people have been reading previous examiners' reports, VCA are focusing on applying knowledge to new context. Every year, there are integrated questions testing key science skills applied to an experimental context. So they're really trying to crack down on students just writing things from their cheat sheet. Most of the questions are now about how is that applied to the context in the question. And really, to do well at VCE Physics now, students need to be able to apply their knowledge in unfamiliar context and really answer the question. So part of something that Edrolo is kind of doing to try and to make life easy for you is we've moved the key science skill question from being its own thing, and we've integrated it into our exam style questions, more similar to what VCAR does. So within this question here, we've got a little key science skill indicator showing that these questions are really targeted at your key science skills. But then there's also part C, which is a normal theory style question. And the examiner's report mentions that students really shouldn't copy definitions, and they're really trying to get students to apply the existing knowledge and answer the question properly. So another thing that Edrolo is trying to do is write down these checklists with the correct command term for how to answer a question properly. So I have identified the magnitude of the direction of the gravitational force, or I have stated the gravitational force is providing the centripetal force. Oh, sorry. Or I have explained, or I've justified my answer, or I've identified who is correct is the classic one. Students will often put theory down, but not even write the simple words of Peter was correct, and they'll often miss out on marks. So another thing that VCAR have tried to do more is really applying knowledge to new context and looking at the changes in the study design. I think that's pretty clear with the new context that they're really adding into relativity. Are there any questions on applying knowledge to new context and kind of the new focus on that? Well, not new focus, but it's been an increased focus on it, really. Cool. The last section I call streamlining your teaching. And this is really just a plug on kind of everything we're trying to do at Edrolo to make the new changes to the study design easier for teachers. So they don't have to think about it. It's all there. And I hope some of my explanations of what the new study design have eased any fears that you have, that there aren't really that many changes. It's more just a rejig in content and more applications of the theory in new context. So with our new textbook that we're writing, we've got a unit plan linked to all the topics and dot points and chapters in the book, so you don't have to worry about it. You can give that straight to your header domain. You'll like it. Again, a lot of the features are similar. If anyone uses our Year 11 book, we got our key terms. The explore boxes, the things I really find useful would be the strategy boxes and the tips, which really help your students get their exam practice in and get their exam technique down. The study design dot points are there, essential prior knowledge if you have students that really need to catch up on certain things, or what's the key knowledge for each chapter. We have worked examples and progress questions. The online platform is very similar. We have video solutions. We are now including some VCAR exam stats. So as much as possible, we've tried to include questions based on previous VCAR exam questions. And one of the things we also are including now in the solutions is the percentage of students who got it correct. And that's a really good indication, especially for your top kids that need to differentiate themselves, which questions are differentiators that'll separate them from other students. Checklists and calculations I've gone over. We've got our spiciness rating, which tried to scaffold your easy, medium to hard questions. And we've tried to roughly put that in the same percentages as what VCAR does, with 25% on your easier side, about 50% in the middle, and your 25% in the harder side as well. We have a deconstructed exam question. So your deconstructed exam question is trying to help break down a 3 or 4 mark question into those 3 or 4 marks. So you take a 4 mark question. What if we broke that into 4 separate 1 mark questions to help a student break it down and bridge that gap between answering a 1 mark question, putting it together into a 4 mark question. Again, I mentioned we put the key science skills there. And I'm in the wrong screen, so my computer's doing funny things. Let's go back to the right screen. And finally, we have theory summaries and chapter area study reviews to help students review before SACs and exams. And finally, I think this would be the last one. Are there any final questions on anything I've spoken about today or gone over? I hope that I've shown you that the changes to the study design are not major. It really just is a reshuffle, which I think has actually been good, especially with moving Newton's law to the start. And really, then apart from photovoltaic cells, the new study design dot points are really just applications of the existing theory that's there. And there's not too much to change in your teaching of the theory.
And we'd shared in the invite for this PL the photovoltaic cells sample chapter, which I know you've worked on, Anthony. So I might even just include it again in the comms that goes after this in case people have missed it. But yeah, there's a sample there so people can see it. Is there anything that you think is likely to trip people up, Anthony, if they're particularly, worried? Like, is there anything I think you've reassured everyone that the changes aren't major, things being shuffled around. Anything you'd be watching for?
I think the thing I'd watch out for is the relativity stuff, because, and particularly with questions, because if students start researching, particularly GPS satellites and stuff, they're going to come across general relativity. They're going to come across all sorts of other information. When really at VCE level, all they can do is ask you special relativity questions on time dilation and length contraction, and the particle or the object cannot be accelerating. So really, it just is a new application of the same theory. So I don't think you need to go out of your way to teach a whole lot of new content there.
And David has asked if we have a sample book available. Not the full book, but we'll be releasing chapters as they're finalized. But you're certainly putting Anthony on notice there to get the book done, David. So
we're trying. We're furiously writing, David.
It's literally, I mean, you can imagine the study design comes out, only kind of weeks, months ago, and of course the team is hard at it, literally rewriting the book from scratch to make sure it kind of perfectly aligns and everything is suited to the new study design. So it won't be too far away, David, but we'll be certainly sharing it now that you've attended this session, as well as the fact that we've got your contact details. So any other questions quickly? Otherwise, we may just throw it to our colleague, Jack, who's going to just quickly give you an update on the book, which is a good segue from your question, David. David's also asked, Anthony, can you include formulae manipulation section?
What do you mean, David? Like how to rearrange formulas, or?
While David answers, we'll just make sure that anyone else, any questions at all for Anthony? And Anthony's contact details are in the slides as well. Yep. So you can certainly reach out to him. And as I said, we'll be sending out the slides and everything early next week. So you can also reply to that email if you have any questions or anything comes to you at 3 a.m. in the morning, heaven forbid. And you're like, why didn't I ask that? While we maybe wait for David to elaborate on his question, Elizabeth has asked, will there be sample assessments similar to what the other textbook companies provide? There are many new assessment types that students may not be familiar with. Will the textbook address these new styles in some form? Good question.
So the online platform has sample tests for you. The assessment styles, yes, they're as part of our activities, we'll have editable Word docs, and there will be some that will try and address every type of assessment type that is in the study design. If you've got the current Year 11 product, we've got activities in there that also address some of those new types from, I think, media analysis and things like that, off the top of my head. So yeah, they'll be part of our activities where we try and model or give students an opportunity to have a go at that.
And similarly, if anyone isn't already using the Year 11 resource, which has been done to this, obviously the study design this year, then do reach out and we can send samples or set you up with a trial or that kind of thing. David, before we throw to Jack, who's patiently waiting, David came back with a clarification, Anthony, saying we have a lot of, this is around the rearranging of formulas. We have a lot of students that can rearrange formula that can't rearrange formula, and they have to teach them that, which takes away time from obviously teaching other content. So hence the request.
Yep.
Content.
So in the Year 11 book, we included the triangles for your simpler formulas with 3 variables and stuff. One of the problems is that in Year 12, there aren't many 3 variable formulas. So really what we have is our essential prior knowledge can help deal with the really basic stuff. So essential prior knowledge is in every chapter. So you're talking about SUVAT in particular more? Is that what you're asking, David? I'll just, essential prior knowledge doesn't have to be part in the study design. So for example, resolving vectors, we have essential prior knowledge questions, which are basic trigonometry. Yes, we have in the SUVAT kinematic stuff, I'd have to double check. We haven't actually written that chapter yet, but we could aim to include something on the rearranging of each formula. I did teach at a number of low SES schools, so I understand your pain in terms of getting students to rearrange formulas. Some of the tricks and tips that we have, especially for Lorentz factor and stuff, is in our strategy boxes, we often provide you with the rearranged formula for a few things. And that was one of the big tips I gave my students, was to just give them the rearranged formulas for a lot of their stuff, for the most common questions asked by VCAR, to try and save them in exams.
Nice, and just some commentary from others around the challenges of that and seeing that with students. So it sounds like it's something useful. Any other questions quickly? Otherwise, we're going to throw to Jack. So we want to get you out of here on time. Great. Well, you're going to stick around for the next few minutes, Anthony, in case anyone pops anything in the chat. Otherwise, over to you, Jack.
Hi team, can you hear me okay, Clinton?
I can hear you.
Hey guys, my name's Jack. I work here at Edrolo alongside my colleagues, Anthony and Clinton and Adam. The first thing I want to point out is in relation to a couple of your questions about sample lessons, we do have plenty of them at the moment. So I'm going to point you in the direction of the chat where I think a colleague of mine will chuck a link in there. And if you fill out some of the information in that link, we'll be able to get some sample lessons in your hands for you to check out. But what I'm going to do quickly, I'm just going to run you through the online platform very quickly and link you to some of the content that Anthony was discussing previously. So the first thing to point out is actually the flexible activities and the pracs that are available for every single lesson, or will be available for every single lesson for the 3-4 book and are currently available from the 1-2. And you can actually access them just by clicking on the attachments button next to each lesson. A little drop down appears. You've got those Teach and Tech Word docs and the student doc as well. Now, the next thing I wanted to show you, and this is personally, I'm just going to go back to sharing. I've clicked the wrong button. Here we go. Yeah, this is actually my favorite part of the resource personally, but all of the questions in the PDF or the hard copy textbook are actually embedded on the online platform as well. And what this means is that students can engage with these questions online. And then as teachers, you get all the relevant data insights that flow through from that. So this is just a student workflow here, what you're looking at right now. I'm just going to enter a sample answer, click submit. As soon as I click submit as a student, I'm presented with a couple of things. The first thing is that we've got a checklist to engage with. So as students answer the question, they can compare their own answer, as you can see right here, to the exemplar response. You can also mouse over these, where students can see where all the exact marks within the response to the question exist. Now, this is where it gets even more interesting. As a teacher, this information is available for you in your teacher Edrolo account. So when you click on the review responses button for a particular question set, this is going to take a second to load. You've actually got all of the data available from your students' responses to those textbook questions. You can actually see where students have gone right or wrong, as well as the specific marks they got in response to the specific question that they're answering. That's just a quick walkthrough of the platform, guys. I don't want to overwhelm you and get you out of here on time. But yeah, if you have any questions at all, feel free to get in touch with your Edrolo rep or click that link